Welcome to the Solid Mechanics Lab at UTEP. Today we're going to talk about the mass spring system. The objective of this experiment is to measure the stiffness of different springs and to measure the time period of oscillation. We have three different springs, these two and another one already been put in the setup. The setup can be divided into three different parts. First, the top adjusting assembly, and then the guide bush that's going to make sure that the spring is straight and in center, and third, the loading platform where we're going to put our weight plates on. We have 10 different weight plates with 400 grams each. And in order to measure the deflection, we need a linear scale or measurement device, and we have this scale, so it's going to give us a deflection in the scale of millimeters. So we're going to put these plates, weight plates, on the deflection on the assembly system, and we're going to measure the deflection through this scale. Before the experiment, the spring's height, the number of coils, and the diameter of the coil should be measured, and we can do that using these slide calipers. Now, the first step for the experiment would be to determine what's the length in an unloaded position of the spring. And from these measuring device or from this scale, I can measure it. And in order to do that, I fix the one end of this scale on a datum point or on a fixed point up to the height of the very last coil of the spring. And I can see that the height is 170 right now, 170 millimeter without any weight plates. Now I'm going to put the weight plates on the loading platform, and I'm going to measure the height again. It went up. Right now it's 170, so I can tell that there is a 10 millimeter of deflection because of 4 grams of weight. I'll keep repeating the same process for all 10 of the weight plates, so 4 kilo. So for the second objective of this test is to measure the number of oscillation over time, or the time period for each oscillation. In order to do that, we have this spring already been set up, and we put 400 grams on the loading platform. I'm going to push it down a little bit, and my assistant over here, he's going to measure the number of oscillation and the time with the stopwatch. Ready? Okay, so apparently we got 6 seconds, 39 milliseconds for 10 oscillations. So for the third objective for this experiment is to compare the stiffness of different springs. So far we have demonstrated using this spring, and right now we're using the heaviest spring that we have in the lab. In order to measure the stiffness, we have to get the deflections, and without the loading conditions I had 180, and right now with 4 kilograms on the loading platform I have 195. So I can, if you remember from the previous experiment, is that for the other spring we had a total deflection of almost 65 millimeter for 4 kilograms, but for this one we have only 17 millimeters for 4 kilograms. So that gives you an idea how heavier or how much higher stiffness this spring has compared to the previous one. Now I'm going to see how this stiffness is going to affect the time of oscillation. So my assistant is here, he's going to take the time with stopwatch. Start, ready? Okay, so we have a time reduction from almost 7 to almost 670 for 4 kilograms between the easier or lower stiffness and the higher stiffness spring.